Chapter 1, Section 1.2. Here we look at random samples. Focus points in this particular section. Explain the importance of random samples. Construct a simple random sample using random numbers. Simulate a random process. Describe stratified sampling, cluster sampling, systematic sampling, multi-stage sampling, and convenience sampling. So you see there are different kinds of sampling. We want to understand what they are. Okay? Simple random samples. In this section, we will examine several widely used sample techniques. One of the most important sampling techniques is a simple random sample. A simple random sample of n measurements from a population is a subset of the population selected in such a manner that every sample of size n from the population has an equal chance of being selected. All right. So what does that mean? So suppose I want to understand, height of people in New York City, right? Height of people in New York City. So I'm not going to be able to go and meet everyone living in New York City and measuring their heights. So I will take a sample of, say, 20 people. Now, which 20 people do I select? If I select 20 people randomly, truly randomly, then there should be absolutely no bias involved. That's what random means. In other words, the chances of me selecting one group of 20 people must be the same as the chances of selecting some other 20%. All right? So that's what it means. The simple random sample of n measurements from a population is a subset of the population selected in such a manner that every sample of size n from the population has an equal chance of being selected. In a simple random sample, not only does every sample of the specified size have an equal chance of being selected, but every individual of the population also has an equal chance of being selected. Okay? So not only every group, but every individual. It should not so happen that I select 20 people by choosing husband, wife, husband, wife, husband, wife. So in essence, I have only chosen 10 groups of people. You see, husband, wife team. So that tells me every individual did not have the same chance, because say I selected 10 women and then selected their respective husbands. The husbands were selected based on the women chosen. In other words, the husbands were not randomly selected. So there was some kind of bias on my part, right? I chose 10 women randomly and then their respective husbands. Now you may ask, what is the bias here? The bias here is that I'm assuming all the women I will select are married. So such biases shouldn't creep in. So in a simple random sample, not only does every sample of the specified size have an equal chance of being selected, but every individual of the population also has an equal chance of being selected. However, the fact that each individual has an equal chance of being selected does not necessarily imply a simple random sample. Remember, for a simple random sample, every sample of the given size must also have an equal chance of being selected. Okay? Now you are going to use random number table to pick a random sample of 30 cars from a population 500. Now, how do we do this? Well, we are going to use a certain table. Okay, it is in your appendix. So, the appendix of the textbook, you will find it in my lecture notes towards the end. Okay, so you will find, so you see this is table 3, table 3, table 2, formula sheet. This is something else. Here is table 1, random digits. All right. So, what are they saying? They are asking me, has 50 rows and 10 blocks of each, right? So, there are 50 rows. These are the rows, and each row has 10 columns. Okay. Now, it can be thought of as a solid mass of digits that has been broken up into rows and blocks for user convenience. Okay. Now, how do we read digits? Well, right now, in this particular example, well, we drop a pin on the table and head of the pin landed on row 15, block 5. So, row 15, block 5. So, let's look for row 15. 1, 2, 3, 4, 15, block 5. 1, 2, 3, 4, 5. So something like that. So we are going to start from 9, 9. So they are using a different random table, guys. That's what this means. I'm not getting the same numbers, right? Row 15, block 5. 1, 2, 3, 4, 5. So my block begins here, but theirs begins somewhere else. Okay. So the point is, you choose a random table of your liking, drop a pin somewhere on the paper, and start where it goes. That's how random you choose, right? So in this case, they have these numbers, right? These are their numbers. So for us, it might have been somewhere here. All right. So these are their numbers. Now, what are we going to look for? We want 30 cars. All right. So if I'm starting on 30 cars, these are the digits you have. Since the highest number assigned to a car is 500, remember our cars were numbered 1 to 500. So that's a 3-digit number. Okay. So because it is 3-digit number, you take this line and break it into 3 digits, you see, like that. So they have broken it into 3 digits. Okay. Now, we want to get the first 30 cars. Look at that. That's the first number. But that's beyond 500. So drop it. Second number, that's also beyond 500. So drop it. Beyond 500, drop it. This is the first acceptable number. Okay. So we are going to drop these 3 numbers and start here. Sorry. So you get 015, which is 15, right? Then 221, 105, 37. They are skipping something. Let's look at what they have skipped. This is okay. This is not okay. Not okay. Not okay. Why? Because they are beyond 500. And then go here and then go here. All right. And then continue. And how do you continue? Once you have reached the end, go to the next line and continue. All right. If we encounter a number we have used before, skip it. Okay. So here is the procedure to draw random samples, truly random sample. Draw a random, number all your members of the population sequentially. Use a table like here, or a calculator or a computer to select random numbers from the numbers assigned to the population. Create the sample by using the population numbers with the numbers corresponding to those randomly selected. Okay. For the next slide, we will start on the next video. Okay. Until then.